So in ping and traceroute, the first difference, the basic difference is the ping is and traceroute, they both are network diagnosis tool. As I just said, they are command line utility, and the traceroute is not only command line, but it can also be seen. There are utilities available. So a ping is a command line tool that is available on all platform. In traceroute or TRACERT, it is a utility that differs depending on the platform, because the source and destination, both the thing ping and traceroute, they go from source to destination. Traceroute also goes in between. So traceroute is in Linux and Mac. TRACERT is for Windows machine. That is why it is platform dependent. Okay, now coming to the actual command, what do we write? So the difference is, for pinging, you just write ping in a command prompt and then followed by the IP address. And there are various parameters you can use. So ping with the IP address or ping with the domain name. That is google.com or say yahoo.com. So there are 4 packets which goes, they come back, round trip time is known, and then you get how many packets are sent, how many packets are dropped, how many packets are received, how many are lost. So this is what ping does when you actually type ping with the IP address. In TRACERT or traceroute, they both are same actually for different platform. So how do we actually write TRACERT? Same thing. In place of ping, you just write TRACERT and then you write the IP address or the domain name. Like for example, here the example google.com is being written. So C:/TRACERT followed by the IP or the domain name. So what exactly is done? 3 packets are sent to all the network devices, or you can specifically say routers, and the packets come back and the round trip time is known from that router, and from this timing you know where is the problem actually existing. The other difference is ping is used to determine whether a network data packet can reach an address without errors. That is from only source to destination and destination back. From the destination back to the source. Okay. We send 4 packets from in the ping, you get 3 packets. Oh, there is a loss of 1 packet. But the traceroute assists in mapping data on the internet or the network from its origin to the destination. That is, not only the source and destination is involved, but all the routers in between. The packet is sent to each and every router, and the packets are being, returned back. And the time of all these 3 packet round trip time is known. This is best of 3 actually. Ping calculates the time taken by echo reply request based on the response from the network address of the server. So in ping, we send ICMP Internet Control Message Protocol echo request. It goes to the server. Now server sends back the ICMP echo response, and from here you get the round trip time. This is how the ICMP is used in the background of ping. But in traceroute, there is something different happening. It takes the TTL. TTL is a field in it's a 8-bit field in your IPv4 address. If you see the IPv4 header, you will find it. So TTL it uses. When TTL is 1, it sends the TTL as 1, it goes to the first router, because TTL is always decremented by 1. Whenever it becomes 0, that packet will be dropped. So first source will send the TTL equal to 1 packet to router 1. Router 1 will reply back. Then next one is TTL 2. This, because whenever the TTL becomes 0, there will be ICMP TTL exceeded. So the packet will come back. Then TTL will be 2. This is the first row I'm showing. This is the first router responding. Okay. So you get the round trip time for the first router. Now TTL becomes 2. At TTL 1, it will become 1 at the first router and 0 at the second router. So the second router will again get an ICMP TTL exceeded. So it will return it back. So the 3 packets will return back. This is the second row I'm showing. That is the time of the round trip time from the second router. So this go on and on. First line which you see the IP address is normally your network address. Okay. In between you have all the network in the world. And the last but one is normally the network address of the last network, or the address network of the actual destination. So you get exactly the time and you can find out where the problem is. So the next difference in ping and traceroute is the underlying technology. Ping uses or employs the ICMP, as I just suggested, Internet Control Message Protocol, echo packets to determine packet loss and the return time to its destination. Okay. So ping sends the echo request ICMP and the server or the destination respond by ICMP echo response. In traceroute, on the other hand, employs both the ICMP along with the UDP, which is the user datagram protocol data packets to determine the packet loss, return time. It depends on the platform as well. Okay. Ping is unable to determine the route or path to the destination. That is the only difference, basic difference. What all in between networking devices are coming, routers are coming, ping doesn't know about it. It only knows about the destination. But traceroute, traceroute, the work is only like that. Traceroute uses TTL to determine the best route to the destination, to find out the route, whole path where the problem may be. If you are accessing some web pages, it is very slow. From which router it is actually becoming slow. So you get the time, the return time of the packet, and you know, oh, this router is creating any problem. And this is how IPv4 header time to live is used in traceroute or traceroute. The TTL or time to live value of a ping packet cannot be modified. Once TTL is given, that will be final. TTL is an 8-bit field. If you see the IPv4 header, you'll get it. Okay. So if you are saying 30 hops, it will only go to the 30 hops. It will not reach the destination if the destination is higher than 30. But traceroute broadcast an incremental TTL until the source or maximum TTL is reached. TTL1 goes to first router, TTL2 goes to second router, like that. Okay. So you need to check, if you're a gamer, what do you want? You don't want any latency. For that, you can use ping. You can use also traceroute, because for gaming, you need to know whether if you ping and if you get less than 1 millisecond, you can play the game. But if you get less than, say, 200 millisecond or 500 millisecond, then the latency is very high. So the game cannot be played. For video conferencing, you can use traceroute. You know that there is some problem because video conferencing is generally a wide variety, continental kind of stuff. So you know exactly where the problem may be, if the problem is. Okay. Where is the hop delay? Which router is actually, which hop is creating a problem?